Is a program for secant method using an equation which is a transcendental equation. We will solve this equation that's shown using this secant method calculator. Here we declare double from x sub o to x sub 1 to x sub 2 to the accuracy e and to the precision p. And we declare iter initialize to 1, the iteration shall start to 1 and end the number of segments as integer. The double f parameter is a pointer function, and the pointed function takes a double input and retains a double, which means that this function will be called when being used inside the program. So the int main is necessary for every program from this line onwards when the program ends. Here we print out the name of the program, secant method calculator, and also we print out the name of the programmer. So we input also a calculator for transcendental function. We also put the name of the programmer, and we also have it. This one we will print out the two initial values x sub o and x sub 1. For x sub 1 we have in here c in and c out. You have to enter the initial value of x sub 1, and then c in x2. Print out again, enter precision decimal point. Our decimal point here is about 6 for this problem. And C in P And see out, we have to enter the required accuracy, which is point 0.0001. And C and P. Okay, we'll set the fix to the position to the fix C out, print out, and we'll have a tabulated result. Get it out. Uh, that is a table that has the following data: the iter or the number of iterations, and the XO, the X1, X2, the function of XO, function of X1, function of X2, and the accuracy. Okay, we'll do while we will equate XO equals to X1, X1 equals to X2, and X2 equals to X1 by the formula of this one: X1 minus XO divided by the function of X1 minus the function of X sub O multiplied by the function of X1. Okay, we will print out the result now. We'll have it complete by this formula from the iteration that we have. So X1, X2, function of XO, function of X1, and the absolute value also of the X2 minus X1. Okay. Then we'll have it if X2 is equal to 0, then we can now find the root of the equation is X2. And number of iteration, while the absolute value and print it out again, parameter of the table. Now we have print out everything with this formula, the absolute value x2 minus x1, and with the precision, well, accuracy E, the number of iteration, the iteration plus, and print out again. Therefore, after how many iterations, the root x2 will be given, and that's it. The second method for transcendental function. Now let's test and run the program. Okay, let's start the program by entering the initial values of x sub o as 0 and initial value of x1 x1 and the precision decimal as 6 and required accuracy as 0.000001, and the tabulated result now is displayed here after x2, x1, f sub o, f sub son, f function of x2 and the accuracy in the table. For after 8 iteration, the root x2 is 0.72990 by that equation. Okay, thank you. Hi, I'm going to show you the code of the second method calculator, which our Professor Carlos Hortilano IV assigned to us to do. So we have to open the code block first. This is the program. This is an open source cross-platform IDE for this C++ program. So I have already created it previously and I have to open it now. So open an existing project. So I'll click it. And it goes here, the second method, CBP. So click the sources in here. It should, so this is the second method calculator. I'm not going through with this library headers because there are plenty of literature there. If you want to study every one of it, you can have it searched. The purpose of this video is to show you that this program is working. Okay, let's have it run. By the way, I'm going to solve Mr. Hortelanos or Professor Hortelanos' favorite equation, the x cubed minus 4x squared plus x minus 10. Okay. So this is the whole of the program. Let's click on run here. Then the executable file comes out. So this program will obtain the root of function of x is equal to x cubed minus 4x squared plus x minus 10. So it is asking us to enter the two initial values x0 and x1. So for the initial value of x0, let's enter 3. And for the initial value of x1, let's enter 4. For the precision decimal points, I think let's enter 6. And for the required accuracy, let's enter point 0.000, another 0, and 1. So 5 decimal places. Okay, it shows now the tabulated result. After x6 calculation, the root x2 is 4.30613. Okay, so this is now the results. This is now our root. That's it. Thank you for using this second method calculator. We have it in full screen.